Hello, my friends. My name is Gerardo Reyes, and today we will work with the Bayesian calculator and the contingency table. To do that, we will use the following problem. Julia is having an outdoor wedding ceremony tomorrow. In recent years, it has rained on average 50 days per year. Unfortunately, the meteorologist has predicted rain for her wedding day. When it rains, the meteorologist will have correctly predicted it 80% of the time. When it does not rain, the meteorologist will have incorrectly predicted rain 30% of the time. Given this information, what is the probability that it rains on Julia's wedding day, given that the meteorologist said it would? We look at the important information of this problem. It has rained on average 50 days per year. When it rains, the meteorologist will have correctly predicted it 80% of the time. When it does not rain, the meteorologist will have incorrectly predicted 30% of the time. We have that means we have three important statements. To work with the problem, we can suppose that R plus will mean it rains. R minus, it does not rain. P plus, correctly predicted. P minus, incorrectly predicted. With the first statement, it rains on average 50 days per year, we can fill out the total of R plus 50 divided by 365, and R minus will be the rest. Both sum up 1. We go to the second statement. When it rains, the meteorologist will have correctly predicted it 80% of the time. We can also express this as saying the probability of P plus given R plus equals the joint probability of P plus and R plus divided by the probability of R plus. The joint probability is not given by the problem, but we can calculate it by doing some simple math. And the joint probability of P plus and R plus is 0.10958, which we will place in its respective coordinate. We go to the third statement. When it does not rain, the meteorologist will have incorrectly predicted rain 30% of the time. Or we can also say the probability of P given R minus equals the joint probability of P plus and R minus divided by the probability of R minus. The joint probability is not given, but we can calculate it with simple math. And the result is that the joint probability of P plus and R minus equals 0.25893, which we will place in its respective coordinate. Now, with these numbers, we are able to complete our contingency table. And once we have our matrix, we will be able to explore all possible conditional probabilities. So let's begin. The probability of P plus given R plus is 0.8. The probability of P plus given R minus is 0.3. The probability of P minus given R plus is 0.2. The probability of P minus given R minus is 0.7. And we go the other way around and we say the probability of R plus given P plus is 0.2973. The probability of R plus given P minus is 0.0433. The probability of R minus given P plus is 0.702, and the probability of R minus given P minus is 0.9566. We put all conditional probabilities together and we come back to the question. Given this information, what is the probability that it rains on Julia's wedding day, given that the meteorologist said it would? Or the probability of R plus given P plus? Well, it seems that we found the answer. The answer is highlighted in green and is 0.297. But Wait a minute. We will work with these two probabilities to continue our analysis. What do these probabilities have in common? These two probabilities have the same numerator. And if they have the same numerator, we can express them as follows. The probability of P plus given R plus multiplied by the probability of R plus equals the probability of R plus given P plus multiplied by the probability of P plus. That means 0.8 multiplied by 0.1369 equals 0.10958. And 0.297 multiplied by 0.3685 equals also 0.10958. You can do the math on your own. So we could also say the probability of R plus given P plus equals the conditional probability of P plus given R plus multiplied by the probability of R plus divided by the probability of P plus. We fill out the numbers and we come to the result. Now let's continue with the following formula. This formula is another way to express the Bayes theorem. Now, these components in black are familiar to us. We have just worked with them, but the components in red are not so evident. So we have to look for them in our analysis. We are looking for the probability of P plus given R minus, and we are looking for the probability of R minus. Well, the probability of P plus given R minus is 0.3, and the probability of R minus is 0.8639. So we give the numbers in the formula and we are able to compute. Now we come to the result. What is the probability that it rains on Julia's wedding day given that the meteorologist said it would? Well, this is 29.7%. Now let's use the Bayesian calculator to come to the same result. The Bayesian calculator asks us for the prior probability. The prior probability is 0.1369. 0.1369. And the conditional probability, this is probability of P plus given R plus, is 0.8. This is 0.8. And the probability of P plus given R minus, which is this one. The probability of D given H prime. This is 0.3. 0.3. We compute and we come to the same result, 0.297, as we calculated manually. So if you think this video helped you, give me a like and I will be glad to work with you another problem with the Bayesian calculator and the contingency table. Thank you.